When a vehicle has an accident, it is often the case that vehicle body and mechanical elements which have influence on the steering geometry are affected. If we take into account that steering is the most important passive security system in the vehicle, we get an idea of the importance of locating and determining which elements are damaged, so that they can be repaired in the case of the bodywork elements, or so that they can be replaced when it is a case of mechanical parts. In this way, there is a guarantee that the vehicle will recover correct steering geometry. In some cases, it is not possible to detect the mechanical parts which have been damaged until alignment measurement is carried out once the vehicle has been repaired. Dscheck is a computer application which makes it possible to analyze the elements involved in steering geometry on the basis of the alignment information sheet. The alignment sheet provides the values of the different geometry angles, both for the front axle and the rear axle, along with the values determined by the vehicle's manufacturer. The information about the state of each one of these angles is the basis on which the Dscheck program works. An analysis is made through these values of the different elements involved in the steering geometry. The first screen shows us two panels, one for the identification of the type of suspension by make or model, and the other allowing direct entry by type of suspension. The three buttons at the bottom have the following functions. The right button is to leave the program. The middle button is to return to the current page. And the left button gives access to the technical documentation. There is plentiful documentation on steering geometry in PDF format. In this documentation, there is a detailed but simple explanation of each one of the angles involved in the geometry, which form part of the processes of analysis of the Dscheck application. Now we're going to show how the application works by means of an example of a vehicle which has been repaired in the bodywork department. When the alignment was carried out, a geometry problem was detected. The analysis starts with the identification of the suspension system on the vehicle, both for the front axle and the rear. To do this, we access the panel for identification by make or model. The vehicle make is selected, and then the model. Kia Ceed 2008. When the model is selected, the front and rear suspension corresponding to the vehicle chosen show as active on the panel for suspension type. The other types are inactive. Access is possible to the analysis of either of the two axles, but it is logical to start with the rear axle, given that the geometry of the rear axle is directly influential on the geometry of the front axle. Indeed, on entering the front axle section, the system will warn you that the rear axle should be examined first. When the rear axle is accessed, a screen appears which, as well as showing the suspension type, shows the steps which will be followed in the process of analysis. Only the button for the first step of the process is active. The values for the thrust angle must be checked. The model of vehicle selected will always show at the bottom of the screen, along with the type of suspension. In this case, a Kia Ceed with multi-arm rear suspension. The next screen to appear is the first one in the analysis process. The following sections are to be seen here. An image showing the angle in question or the part to be checked, along with the elements or parts involved in that angle. The step to be followed or action to be taken. This is in the white box and tells us what we have to do. In this case, check the values for the thrust angle and see if they are correct or not. Likewise, in many of the steps, we will find the Help button. This Help refers to the step in question, providing clarification of the matter in hand. It may also indicate how the angle check should be made. In the example of the vehicle we are analysing, The thrust angle is 20 minutes, meaning that it is not right, being over 15 minutes. We click on the Wrong button. We will now be asked to check the anchorage points of the axle and the arms for length. The drawing shows in generic fashion what the points to be checked are by highlighting them in colour. The help available shows us how to carry out the check. Since this vehicle has been repaired for damage to the bodywork, we check that the points are correct using the information sheet on the measurements obtained on the repair bench. We will now check the values of the individual toe-ins. In this case, they are wrong. We check the anchorage points, this time for width. We have now checked and established that they are correct. Next, the process asks us to check the suspension arms. We've opened Help, and we can see how to check the arms with a beam compass. This check is carried out by measuring the length of the arm, comparing it with the other arm on the other side. In this case, they are right. The next step is to regulate the toe-ins when this is possible. In this vehicle, it is possible. This is an adjustment which is carried out with the vehicle on the alignment machine. In the following screen, we're asked to check values for camber. These are also correct. If at any moment we wish to go back to an earlier point, click on the arrow. We arrive finally at the check on the rear axle. The route followed can be consulted at any stage by clicking on the left-hand button. As can be seen on the screen, this can be printed to enclose it in the vehicle dossier. Once the rear axle has been checked, the front axle is then checked. We click on the front axle and we don't select the rear axle because we have already done that. In the first place, we have to tell the program if the alignment sheet provides us with the values for the included angle. In this case, it does. In the same way as for the rear axle, the procedure to follow appears on the screen. The first step is the camber. In this case, it is wrong. We are then asked for the included angle. We see that it is wrong. We check the pivot angle, and we can see that it is right. At this point, we are asked to check the steering knuckle. When we click on Help, we see how this check is carried out with a beam compass. When we make the check, we can detect that the uprights are of the same length. In this case, it is decided that the left upright must be replaced, since this is the side on which both the camber and the included angle show values outside manufacturer's specifications. Once the affected part has been detected, it is replaced and a new alignment is carried out. Whenever a part is adjusted or replaced, a new measurement should be carried out since we are facing a new geometry situation. If necessary, another analysis will be carried out with Dscheck from the start.